Hi, welcome to my video on the motion of an object in the air and a particle on a line. Review 2, this is on videos 9 to 12. And as in all my reviews, you can mark your review as a test or a quiz and mark it at a 26. So what you do is you score each question, give yourself a mark, total up the page at the bottom, and add them up at the end to see how well you're going to do. Here we go. A particle moves in a straight line represented by s of t, 1/4 t to the fourth, and negative 7 over 3 t cubed plus 7t squared. And the m represents, this is the position of a particle, s, and m is the meters, and this is the position away from 0. At time t, or at t is 3, is the particle speeding up, slowing down, or neither? So to answer this question, we need to look at the velocity and the acceleration. And if the velocity and acceleration are the same time, then they're speeding up, or the same value. Pluses, if they're both, when I say the same value, if they're both pluses, then, or negatives, they're speeding up. If they're both, one is plus and one is minus, then they're slowing down. Here we go. Let's look at the velocity, which is s prime, the derivative of the position of the particle. So 1/4 t to the fourth, 4 times 1/4 is 1, so that's t cubed. 7 over 3 times 3 is 7, t squared, and 7 times 2 is 14t. So that's the position, derivative is the velocity, and we want to look at that velocity at the v of 3 at 3 seconds. So we'll plug 3 in the place of t and simplify the expression. Here we go. 3 cubed is 27. 3 squared is 9. 7 nines are 63. 14 times 3 is 42. And when we add that up, we get 6. And the velocity is in meters and the time is in seconds. So notice the velocity is positive. So let's look at what we call now the double derivative. And the double derivative is the derivative of the velocity, and the double derivative is the acceleration. So the first derivative is the velocity, second derivative is acceleration. And so we take this trinomial here, and we do the derivative of t cubed, which is 3t squared. Negative 7t squared is negative 14t, and plus 14t, the derivative is plus 14. So we want to do the s double prime of 3, which is the velocity at, derivative of the velocity at 3, which is the acceleration. And we put all them together. I'm just writing this. I only had to do the double derivative of 3. I didn't have to do all this, but I put it in there. So 3 goes in the place of t. There it is. And we simplify it. We square first. 9 times 3 is 27. 14 times 3 negative is 42 plus 14. And that adds up to a minus 1 meters. And velocity is meters per second. Acceleration is meters per second squared. So you notice at 3 seconds, the velocity is positive, and the acceleration at 3 seconds is negative, and they're different signs. So that means that at 3 seconds, the particle is slowing down. So that's one question done. Let's do a couple more. This is the second one. Again, we have a position st of a particle, and we've got 2/3 t cubed minus 4t squared plus 6t, and m is the number of meters, and that's away from 0, and time starts at greater than or equal to 0. Is a particle moving along a line, in a straight line. Find the time when the speed is increasing. So to find the time when the speed is increasing, what we have to do is look at the velocity and look at the acceleration and see when the speed is increasing, when they're both pluses or both minuses. So let's have a look at the derivative. So the derivative of the position curve, 2/3 times 3 is 2t squared. Negative 4 times 2 is negative 8t. And derivative of 6t is 6. And so we look at, we want to find we take the 2 out here by factoring, because that's a 4t plus 3, and that's derivative, so that's 2, that's t, bracket t, factors of 3 are 3 and 1, product is positive, sum is negative, so negative 3, negative 2. So that makes it, what we do, we make t prime, which is the velocity, again, the velocity, and we make the velocity equal to 0, so that means we go 2 times t minus 3, t minus 1 is equal to 0, so t minus 3 is equal to 0, or t minus 1, let's make that a minus 1, equals 0, so t is 3 and t is 1. So the velocity, let's see, let's draw a little, what we call a line, and on that line we'll put s prime t, which is the velocity, and we have 1 second and 3 seconds, so we put the time is, this is time, so we just put t here. Time is 1 second and 3 seconds, so because it's a quadratic, we have to look at the values of t greater than 3, in between 1 and 3, let's call it a 2, and between starting at 0 to 1. So if we put any number, if we take a half here, and we put a half in this expression, so if you put a half here, a half is positive, negative, negative. So a half is positive, negative, negative. So that is a positive. Now we put a 2 in. If you put a 2 here in place of t, that's a plus, that's a minus, and that's a plus. So that's a plus, minus, plus. So that's a negative. So for the time between 1 and 3, it's negative. And at 4, put a 4 here, that's plus. Put a 4 here is plus. Put a 4 here is plus. So a 4 is a plus, plus, plus. So that's a plus. So that means, because that's velocity, that means if it's positive, it's moving to the right. If it's negative, it's moving to the left. And if it's positive, it's moving to the right. So between 0 and 1 is moving to the right. Between 1 and 3 is moving to the left. Greater than 3 is moving to the right. Now, we want to look, that's the velocity. Let's look at the acceleration. The acceleration is at, which is the derivative of the velocity, which is the double prime of the position function. And so we have this is single prime, that's the velocity. So 2t squared, derivative is 4t. Derivative of negative 8t is negative 8. Derivative of 6 is 0. And so we have the acceleration equal to 0, double prime equals 0. So that means 4t minus 8 is equal to 0. 4t is equal to 8. Divide by 4t is equal to 2. So we draw another line. And this time we'll look at the acceleration, or we'll look at the velocity, whatever symbol you want to use here, they're all the same. So at 2 seconds, and we got to look at it as 0. So what happens between 0 at 0? We have let's go back there. 3 is a 0 velocity, and 1 is a 0 velocity. Okay, so right here at 2 seconds, the acceleration is a 0. So what happens at between 0 and 2? So take a number 1, put a 1, put a 1 in here, and 1 gives you 4 minus 8 is 1 gives you a negative, and between 2, when you put a 2 in here, you get a 0, and when you put a 3 in, you get a 12 minus 8 is 4, so greater than 2 is plus, the acceleration between 0 and 2, the acceleration is negative, between 2 and 3, the acceleration is positive. Now, if we take the two of these and put them together, and I'm going to do this, this is the v of t, and let's put the acceleration right here. So I have a 0, 1, and 3, so there's a 0, I have a 1, and I have a 3. So down here I have a 0 and a 2. So there's a 0 and a 2. So I have to take the 2 and put it in here also. And right here I had to put the 1 in, and I had to put 3 in. Now both lines have all the values for t. So in velocity between 0 and 1, we have a positive. Between 1 and 2, we have a negative. Between 2 and 3, oh, I'm putting it in here. I shouldn't be putting it in there. I should be putting it in here, negative and negative. I got to put it in the velocity. I was putting it in the acceleration. So, and greater than 3 is positive. So let's look at the acceleration between these. Remember, this is not there. So let's look at here. Between 0 and 1, it's a negative. Between 1 and 2, it's a negative. Greater than 2 is positive. So between 2 and 3 is positive. Greater than 3 is positive. Now we have all the intervals filled in. So again, it says where is the speed increasing? So it's increasing where we have 2 negatives. And so it's increasing in this interval right here between 1 and 2 in union with, and it's 2 of them are the same here. So that's the interval greater than 3. So when both of them are the same signs, which is here between 1 and 2 and greater than 3, so that's when it's increasing in these two intervals. So the speed is increasing. Speed is increasing between 1 and 2 and greater than 3. Oh, and what I forgot to do, I got to go back again. I forgot to put some marks on the. So if you did this and got your 6, there's 2 marks there. If you did that derivative and got a -1 there, and if you said it's slowing down because they're both, one is negative, one is positive, then you got 5 marks. I forgot to do the scoring. And on this question, here I would give you a mark for that, and I give you a mark for the 3 and the 1, and I give you a mark for this chart. And here I give you a mark for that derivative and getting the 2 and getting that chart. And when I line the 2 of these up, I would get a mark each, putting all the time intervals in, pluses and minuses. And when you write this out correctly, then you get another mark, so that's 10 there. Okay, we have one more to do. The end is on the motion of the particle and an object in the air. A particle moves along a straight line where its position is st, and we have 4t cubed minus 12t squared plus 20. M is the number of meters from 0. Time is greater than or equal to 0. S is the distance from 0. T is the time in seconds. We want to graph this movement of this particle. So what I have is, I have an st here, and st is in meters, and let's put 0 here. 0 is the time. So if you put t is equal to 0 in this function, that's the position that the particle is starting off. So I'm putting 0 in for t. So that's a 0 minus 0 plus 20. So that means that this particle at 0 seconds is starting off at 20, right there. But what we don't know, if the particle is going left, right, or remember the particle is moving along in a straight line. So let's look at what we call the derivative. Let's look at the s prime of t, which is the velocity. So here we go. We're doing the derivative. 4 times 3 is 12 t squared. Negative 12 times 2 is negative 24 t. Derivative of negative 20 is 0. So if we make the s prime of t equal to 0, what we have 12t squared minus 24t equals 0. 12t is common factor, so we take out the 12t, we get t minus 2 equals 0. So 12t is equal to 0. T minus 2 is equal to 0. So t is equal to 0. T is equal to 2. So the derivative, which is the velocity is equal to 0, is when the particle is at rest. So the particle, and again, I'll draw a line to represent the velocity. So the velocity, vt, and s double prime. Oh, not s double prime, just s prime. Double prime is acceleration. So at we got 0 seconds, and we have 2 seconds. So what happens if you take 1 second and 3 seconds? At 0 seconds, the acceleration is 0. So it's not moving at 0, and it's not moving at 2. Okay, so it's 0. At 1 second, between 1 and 2, if you put a 1 here, you get a positive. You put a 1 here, you get a negative. So a 1 is a positive and a negative, which is a negative. Take a 3 and put here. 12 times 3 is 36 positive. Put a 3 here, you get a positive. So a 3 is a positive and a positive, which is a positive. This means that at 0 and 2, the particle is stopped or at rest. Between 0 and 2 is negative, which means the part between 0 and 2, the particle is moving to the left. And because 3 and 4, etc., will give me a positive, after 2 seconds, it's moving to the right. So that's what this is telling me. So if it's moving to the right again at t is equal to 0, and that's the same as here, that means the s of 0 is going to give us 20. So this is the position here, so 0 is a 20. So what's t, and t is 2, going to give me? So when I put the s of 2, I'm going to put 2 in here for position. Where is it? 4 times 2 cubed minus 12 times 2 squared plus 20. And we work this out. 2 cubed is 8. 4 eighths is 32. 2 squared is 4. Negative 12 times 4 is negative 48 plus 20. You add all that up and you'll get a 4. So that means that at 2 seconds, or let's do here, 0 gives you 20, which is what I did here. Okay, 0 gives me a 20, and 2 gives me a 4. So that means at 2 seconds, the 20 is here, 4, let's say 4 is down here. So that means that 2 seconds. So you can see that if 2 gives you 4 and 0 gives you 20, you can see between 0 and 2 is moving to the left. And that means after 3 seconds, or 2 seconds onward, it's going to go to the right. Okay, so let's look at the double prime. Let's look at, this is double prime of the t. So we get the derivative of s prime. So that's 12 times 2 is 24t, and that's negative 24t. The derivative is negative 24. Again, this is the acceleration, which is your velocity, derivative of your velocity, which is your double derivative of your position. And so we make the double prime, the acceleration of the derivative of velocity equals 0. So we get 24t minus 24 equals 0. Let's make that a 4. 24t equals 24. Divide by 24 and I get 1. So that means I got an acceleration. So that's a-t, velocity, or double prime of the t. So at 1 second, there's 0 seconds. So that means at 1 second, your acceleration is 0. Between 0 and 1, if you take this derivative here, if you put a half in, here, you get a 12 minus 24 is negative. And if you put a 2 in, here, you get 48 minus 24, which is positive. So this means that at 1 second, just look at what where 1 second is on this movement of the particle. So again, okay, so I'm getting ahead of myself. That means that between is negative, so that means between 0 and 1 second, negative, so it's like a concavity, it's moving to the left, and after 1 second, it's moving to the right, it's concaved to the right. Let's see what happens there. What about t is 1? If t is 1 in this, so the s of 1 is 4, 1 cubed minus 12, 1 squared plus 20. So I put 1 in here and in here, and that gives me 1 cubed is 1, that gives me a 4. 1 squared is 1, gives me negative 12 plus 20. And if I add that up, I get a 12. 24, I get a 12. So that means at 1 second, the position is 12. So at 1 second, which is between 0 and 1, you have a 12. So what you see is that it says between 0 and 1, between 0 and 2, the particle is moving to the left. It went from 20 to a 4. And greater than 2, the particle is moving to the right. And at 1, which is the acceleration is 0, we have a concavity. So let's draw this particle moving. So it starts here, swings over to the 2, over to the 4. So there's the particle. Then it turns and it goes back the other way. So there's the particle movement on the line. So it starts at 0, goes left towards 2, which is 4 meters, and then it swings right. And this point here is what we call a reflective point, inflection point, in terms of the polynomials. So at this point, when time is 1 and this is 12, at this point right here, she's concave to the right. You can see it. It's not a concavity. Positive would mean that it would move upward, but it's not a polynomial. It's a particle on a line. So notice it's instead of going like that, like if you were doing, I do it here. If you had a polynomial, it would be coming down on a polynomial would be coming down and going up like that as concavity positive. But here it swings to the right as a positive. So hopefully that explains it, but there's marks to be given here. And so I would give a mark for the 20, give a mark for the derivative, give 2 marks here, and you draw this line, put the left and right in, pluses, minuses. You give a mark for the 4, you give a mark for the 1, you give a mark for the derivative, mark for this chart, and a mark for this point of 12, and you got 11 marks altogether. So that brings us an end to this unit on motion of a particle and motion of an object in the air. So you add up all your pages, bring back the sheet, add up all your pages. Hopefully your mark is 26. So if you don't have 26, divide 26 into this numerator, get a decimal, move it 2 places to the right to get a percent. So that brings us to the end of this video on the motion of an object in the air or a particle on a straight line. Thank you for viewing my video and subscribing if you wish. And visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.